Okay, good evening. Let us have one lecture regarding the actuator. Um, as I tell you in the last lecture on Monday, we said that we have three important parts in actuator. Actually, there are four important parts, but from the motor point of view, we have three type of motors which are more important. On Monday, we talked regarding the pure DC motor and how to control that. I saw the task number 13. Some of you have done nice job. Some of you still, I don't know why, but need to improve. Please learn this task because more than the mark which I should give you, you should learn this part because it will help you in any other project and maybe you can do some design job in your free time. By the way, today we are going to discuss regarding the second part of the actuator as the servo motor, which initially I will start to talk regarding the structure and electrical and mechanical part of servo motor, which somehow you should be aware about that. And after that, we have some example, which in that we are going to do the coding for servo motor movement. And at the end, as usual, we have some task that you can send this task and tomorrow task on Monday for me. Then no need to send this tomorrow, but on Monday I expected this task and next task that which related to tomorrow lecture we'll do. And then I think if we can finish this part, just one part which remained that I think on Monday or hopefully on the end of next week, um, our lectures part will be over and we will go for review and some part regarding that means that some review part maybe we can have or maybe not. I should ask a school and confirm the policy. Okay, first of all, what is servo motor? Servo motor is a small device that has a shaft output, and and this shaft can be positioned in some specific angular by sending the servo motor coded signal. As long as coded signal exists on the input line, the servo will maintain the angular position of shaft. If the coded signal change, the angular position of the change of the shaft will be changed. And in practice, servo are used in radio control aeroplane to position the control surface like the elevator and rudders. And they are also used in radio control cars, puppets, and cars, robots, and are extremely useful in robotic worlds. The motor are small, have built-in control security, and are extremely powerful for their size. Even in some security camera, you can use these type of motors to have the better control. In whole, if I want to tell you, if you want to have the precise control of your movement with the angular form, the servo motor is the solution which can be used and you can have them. Okay, then uh, inside of our servo motor, the guts of servo motor is shown in the pictures that I show you here. You can see the control circuitry, the motor, a set of gear, and the case, which are attached together. And you can see also three wires which are connected to these. One is power, one is ground, and another one is control wire. We have some more words regarding these three wires in the um, time that when I tell you how to do the programming for this. We can say that servo motor are electronic device that convert digital signal to rotational movement. Then, in somehow, people can say that this servo motor are something like the transducer, is that they can uh, convert one form of energy to another one, or one form to another form. I mean, the electrical signal to the uh, mechanical move. If we want to categorize the um, servo motor, we can say that we have two sort of servo motor. One is a standard servo that the rotation is limited maximum of to 180 degree in each direction. Another one can be as continuous rotation servo that can provide the rotation ultimately in both directions. These are the type of the servo motor that we can have. Uh, then, as I tell you, we have three parts inside of our servo motor, which can call control device, output sensors, which should tell us that we are in the proper position, and another one is feedback system. There is some concept regarding the servo motor that people will call it closed loop, where it will use the positive feedback system to control the motion and final position of the shaft. Means that you will give the signal and then check that each signal is proper to the angular that you want or no. If it yes, no problem. Otherwise, you should do some more action. Here, the device is controlled by the feedback signal which generated by comparing output signal and some reference input signal. As I said, we will compare that this is some signal that we give and this is something that we want to be. How much difference we have, which people will call it error, and based on this error, they can control the position of this remote. Then this signal is act as the input signal to control the device and is present as long as feedback signal is generated, or there is difference between reference input signal and reference output signal. So the main task of servo mechanism is to maintain the output of system as at some desired value and presence of the noise. Uh, More, if you want to see that how servo motors are work, we can say that they have some control circuit and some potentiometer, or some they call it AKA or aka out, or variable resistor, which connected to the output shaft. And in picture above, the pot can be seen on the right side of the circuit board. This port allows the control secretary to monitor the current angle of servo motor. Then, if the shaft is at the correct angle, then the motor shaft off. If circuit finds that angle is not correct, it will turn the motor until it's at the desired angle. The output shaft of servo is also capable for traveling around 180 degree, and usually it's somewhere near to 210 degree, 210 degree range. However, these can be varies depends on the manufacturer and the company that made the servo motor for you. Please note that the normal servo motor will use to control the angle between 0 to 180 degree. and it's mechanically not capable of turning any feather due to the mechanical stop built in the to the main part of the gear. And the power applied to the motor is proportional to the distance it needs to travel. So if the shaft needs to turn a large distance, then the motor will run at full speed. If it needs to run on the small amount, the motor will run at the slower speed. This movement, they call it proportional control, means that which related or based on the movement that you want, you can um, inject or insert the voltage inside of that. Let us see inside the servo motor. You can see we have some electrical motor, which is generally it's DC motor. Then we have some gear. We have some gear, which inside of this gear, okay, well, you can see that inside of this gear, we have some support different type of the gear, which can limit and also reduce the speed of our main DC motor. And here we have some cross horn which can be attached to any other object. If we look at a servo motor from outside, we can have this shape. This is the rotary part. These are some parts that you can fix and some motors, which is the servo motor. And if you want to see the inside, from inside, this is the gear, this is the push rod or any other which is not related to our topic, but it's good that you know that the mechanical part limitation and circuits that we have. Anyway, but something that you should know is this, that angle at which the servo is turned. The control wire, as we tell you that we have three wire, one is VCC, one is control, and another one is ground. With this control wire, it's used to communicate the angle, and the angle is determined by duration of the pulse that is applied to the control wire, which people call it pulse code modulation or PCM. Then the servo expect to see the pulse every 20 milliseconds, which or 0.02 second. In the length of pulse will determine how far the motor turns. Then a 1.5 millisecond pulse, for example, will make the motor round for 90-degree of position. What I mean that we learn the PWM. Then, as even I show you here, this motor will work based on the PWM principle. And when based on the duration of on and off pulse of this PWM, you can move the servo motor. Please note that if the pulse is shorter than 1.5 millisecond, then the motor will turn the shaft closer to 0 degree. And if the pulse is longer than 1.5, then the shaft will be closer to 180 degree. I show you some figure here, which is some standard form of the servo motor movement that you can see here, that the pulse width and movement of the shaft, how it will be and what should be the relation between the pulse on and 180-degree of servo motor. Okay, let us see then. That was the mechanism. Let us see some application for our servo motor. We can have lots of application in robotics world. At every joint of the robots, we connect some servo motor, thus giving the robot's arm its precise angle. We can use them in conveyor belts as two servo motors move, stops, and start the conveyor belts carrying product along to the various stage. For example, in product packaging, bottling, and labeling job. We can see them in camera autofocus, which is highly precise servo motor built into the camera and corrects a camera lens to sharpen out or focus images. And some application we have in solar tracking system, which are the servo motors adjust the angle of solar panels through the day, and hence each panel continues to face the sun, which result in maximum energy of sun up and sun down. And think all these application I show you previous time on some videos, and but that time you didn't know that the motor that they used was servo motor, but now we are clear that the motor was servo motor. Okay, let us go for now our topic. From this part we need the data more, but that data is good for your general um, knowledge regarding the servo motors, which in servo motors, as I bring the figure here for you, uh, you can see that we have three wire. We generally, with a small one which we work, we have the red wire, it's generally 5 volt, brown one which is generally used as ground, and we have the yellow one which is used for PWM. We work already with PWM pin, and we know that suppose in the Arduino board, they specify these pins with some special uh, icon on the bread on the board. Then the best things about Servo is that it can connect directly to the Arduino, and we don't need any driver. Okay. Then now we will see some good things. Suppose in the term of DC motor or a stepper motor that tomorrow I will teach you to a stepper motor. Here we don't need any driver, and you can directly connect your motor to uh, the board. But you should be think of this, that do not try to rotate the servo motor by your hand, as you may damage the motor. And now you know why. Because inside of this motor, you have some gear which will going to break. Then if I want to connect my Arduino board, connection or hardware connection is not difficult. I just need 5 volt, ground, and one pulse pin, which is specified on my board. Suppose on Arduino Uno, pin number 9 or some other pins are specified for PWM. I can use them for the servo motor and directly connect the power and ground pins directly to Arduino board, and PWM pin inputs will be connected to one of the digital output pins. Servo are controlled by PWM through the control pin. Okay. Now, nice job that they have done for servo motor is that they made the library which they call it servo.h. Um, we have some good libraries. Suppose for LCD, we have liquid crystal.h, as you remember. That was very nice library. It has lots of good part that we could use it. Here also we have servo.h, which inside of this servo.h, you can use 12 motor on most of the Arduino board. This is fantastic, and one of the nice job that they have done inside this library. Suppose if we use other boards like Mega and Dewey, you have lots of options to use the servo motor. On Mega, up to 12 servo motor can be used, and use 12 to 23 motors by generating the PW. Second thing regarding this library is that we have some function which already they made inside of this library. Attach, attach, write microseconds, read, attached, and deattach. These are the function, about 6 function they made. And also for inside of the IDE, they made 2 examples. One is knob and another one is sweep, which in knob they control the shaft of servo motor by turning a potentiometer. We'll do today. And sweep is sweep the shaft of servo motor back and forth. This is something that today we will review this example. But before that, let us see what are these function and how they will work. Suppose the first function is attach, which is going to attach the servo variables to a pin. And as you know, in Arduino, the servo library supports only servo on 2 pin of 9 and 10. The format is like this: servo.attach pin and servo.attach min and max, which min and max are optional, which you can give the minimum pulse and maximum pulse in microseconds corresponding to the minimum and maximum, means that 0 and 180 degree. I advise you that don't use the minimum and maximum. As the example as a written here for you at down, you can use just you use the library of servo.h, and then servo my servo, and then my servo dot attach 9. It means that I attach my servo to pin number 9. Well, this is the first function. Second one is write, which it will write the value to the servo motor and control the shaft accordingly. On a standard servo, this will set the angle of the shaft in degree and moving the shaft to the orientation. On continuous rotation servo, this will set the speed of servos, 0 being at the full speed and 180 being to full speed in the other, and a value near 90 being no movement. Note this point. How should be the syntax? Syntax is very simple. We write servo.write an angle, and parameter is that servo is the variable of type servo. Angle is the value to write to servo from 0 to 180. Then the example is very simple. We just need the servo.h. My servo, in the setup, we will say the pins that will attach it, and then write 90, means that we will go to the 90 degree or mid value of our servo. Next one is write microsecond, which is write the value in microsecond or microsecond, like that, as we'll show, to the servo and controlling the shaft accordingly. On a standard servo, this will set the angle of the shaft on, and on a standard servo, a parameter value of 1000 is fully counterclockwise, 200 is fully clockwise, and 1500 is in the middle. Note that some manufacturers do not follow this standard very close, and it may have another value which you should see their data sheets of your servo motor. Syntax is very simple. It's servo.write microseconds, and then in servo you will write a variable of type servos, and in microsecond you will put the parameter in the microseconds. Some example I bring for you here is that that you use servo, my servo, In void setup, first you will specify which pin you connect your Arduino board, and at the next you will say that my servo write microsecond, which will go to the midpoint. The next function is read, which read the current angle of the servo motors, the value passed to the last call, and it's used to have some feedback. And the angle of the servo motors will from 0 to 80 will returns from this uh, function. This good or this function is used whenever you do something like this, that you will send the pulse to the motors, and then you want to be sure that is it exactly at the desired angle that you need or no. If it's okay, then it can do something. If it's not, then you should again send the angle to that. Okay. Next function is attach, which is check whether the servo variable is attached to pin, or you can see that is your servo motor is working or no. Okay, and it will if it will give two value of true and false. If servo is connected, it will give true. Otherwise, it will give you the false. It's good to check that is your servo motor is working or is in the proper uh, working performance or no. The next function is detach, or with detach is the servo variable from its pin. If all servo variables are detached, then pin 9 and 10 can be used for PWM output with analog. In the other words, if you use this function, you can disconnect your Arduino pin with software methods to the uh, servo motor, and you can use it in another application. Okay, let us see now the some example regarding this servo motor. But before that, just till now, what we talked how we can connect the servo motor. It's not difficult. Just you need three pins. One is VCC, one is ground, and one is control pin, which can connect to some PWM Arduino. Really, Arduino library. It's very simple to control the servo motor, and we can use lots of fantastic job with that. Tomorrow I will show you some movie or one stepper motor application. I should find that movie. But anyway, first even this. As I tell you, the first way start use the library text program. Then this which we do, we will up to you can using name. The servo is important. And we make the object setup for servo and use your this interval important. Yes, in the sub we are is clear. And these I wanted to connect. I connect this pin three that 9 is more attached. And then you can invite the loop this here. Servo 8 and the my choice us move one that will servo. This is the first with movement not change. Servo 180 of my motors up to 1 degree. Okay, the number I have I have 0 angle, I have 90 angle, I have 180 angle. Okay, and then we can see the movement of my servo motor within different angle and movement as example number 2. Okay, in example number 3, again I have some movement, but now I will start from 0 to 180 angle, and this time I connect to pin number 9. Okay, you should use this as ono, not use this mega that I use. Okay, and then slowly I will increase my angle one by one, 0 to 180 degree, and have some delay. And again, when it will reach the 180 degree, I will come down 5 by 5 step and come to the uh, first location that I got. Uh, this is good for auto mover like white methods of uh, movement for servo. Let us see another example. Okay, with some addition things, we can use the some better practice with servo motor. Suppose now, instead of fixing the degree, I will put one potentiometer or one uh, port and connect it to analog pin. And through that, when I will rotate this analog pin, I expected that my servo motor movement will happen. How I should return this? It's not difficult, and this we call it controlling the servo position using the potentiometer. First, I should put the servo.h, and then my servo will take the int port of 0. Then just in setup, I will say that I connect my servo motor to pin number 9. Then uh, I should read the value of analog. Then it's very simple. Just I will analog read and read the value of A0. I just resize this reading between 0 to 123. And then after that value that I read, will put what I will hear. Value of analog can be different between 0 to 1 and to 23. But what I chosen in the I between 0 to 180. Very simple. I will tune this or map this standard and change the numbers and just load it. Very simple. That you can use the numbers. This method you can see the movement of uh, your servo motor. Okay, uh, these are for as the task number 40 or for example. That please read them, and then if you had any question, you can ask me on WeChat. Do the simulation. Please try to add the clips for that. Then I will understand that you know how to do and how to do the simulation job with this uh, task, and you understand the servo motor. Okay, it's good. I think we can finish our talk today. Not much more. I will share this PPT by today or tomorrow, and you can follow the task and send it for me on time. If you have any question, please ask me on WeChat as usual. Okay, have a good day. Take care.